Okay, in this question, we have a piecewise function where they've given us two different functions, where one of them is in effect if x is less than -1, and one of them where it's in effect if we're greater than or equal to -1. And they're asking us to graph this function. Now, we can use Excel to do that. We'll need to make a column for x, a column for function a, and a column for function b. Now, we need to decide what x values we want to use to make this graph. Now, since the question says that we want to find f of -5, I suppose let's start from -5 and then go up by steps of 1 every time. How about -5 to +5 might be a good place to graph. Now, function a here is only good if we are less than -1. So let's just apply this formula for our numbers that are -1 or lower. So we'll use function a starting from -5. That'll be x squared plus 3x minus 1. So in Excel, start by saying equals x raised second plus 3 times x minus 1. Then we select the box and take the black cross, but we're going to stop at -1. Now for function b, that doesn't even start until -1. So we're not going to do anything for function b here. We're going to go over here to -1 and enter that. So equals 3 times our x plus 4. Then, once again, take the black cross and autocomplete that. So now that we've done this, to graph, go to Insert, Scatter, and make sure all 3 columns are selected. So we're going to get all of these. Insert, Scatter, which is the dots here. And so this would be our graph. Now, one slight modification that I'd like to make here. Our function a is supposed to actually stop the instant before we reach -1. All right? So we're going to have to say that this circle right here at -1 is going to be open. And then this circle at -1 is closed. Okay? So slight modification on our graph. The reason why is because we have strictly less in piece A. All right, and then we have greater or equal in piece B. So if it ever says strictly less, that means it is open. And then if it is greater or equal, it's closed. So remember that function A is going to be the blue dots. Function B is going to be the orange dots. So if they want the graph, we've given it to them. And if they would like the value at -5, that's going to be this value right here, which we know has to go with function A because -5 is less than -1. So our answer will be here. Here's another type of question where they say the percentage of new car buyers who used the internet for research or purchase since 1997 is approximated by the following function, where t is in years and t equals 0 is January 1997. They've given us another function A and function B. And they want you to find the limit as t goes to 1. So what we need to do to find the limit is to check both functions, because you notice how t equals 1 appears in piece A and in piece B. So since 1 appears in both functions, we need to check them both and make sure they agree. So if they agree, you have a limit. But if they disagree, then the limit doesn't exist. Let's put our t here, function a here, and function b here. So let our t be 1. Type in function a, which is equals 12 times t, add 15. And then do it again for function b. So equals 15 times t, add 12. And we get 27 for both. So the limit is 27. Now, if those two numbers weren't the same, then there would be no limit. It wouldn't exist. Now for everybody's favorite part, interpreting in context of the problem. So for this, we need to take a moment and reread the problem. It says that we are modeling the percentage of car buyers who used the internet in years since 1997. So let's remind ourselves that if t equals 1, then that's 1 year after 1997, which is 1998. So we can say in 1998, approximately 27% of car buyers used the internet to make their purchase. Be very careful around problems that say since a certain year, because you're going to be tempted to use the x value or t value yourself in the answer. But you don't want to do that. You want to take a moment and say, all right, if we started in 1997 and we went forward 1 year, then they're really talking about 1998. So all right, for this problem, they give us a list of months and a balance in an account. And in this problem, we'll go through how to make an exponential trend line and how to use the goal-seek function in Excel. Goal-seek can sometimes be your best friend for some of these problems. So first, let's make a list of months and a list for the balance. And I'll take a moment and type everything in. All right, with everything in here, to make the exponential equation, we select our data and go to Insert, Scatter. So make sure that we get all the numbers in there. I don't think we'll need the words in there. We'll just go to Scatter here and get our chart. Once we have our chart, we right-click on one of the dots and insert trend line. So we'll right-click on the dot. We have the Add Trend Line function. It'll bring up a special menu. We need to tell Excel to do exponential, though, so we'll click the first option. Then we also want to get the equation on the chart, and it never hurts to have the r squared along with it. Just check those two boxes. Move this over here where we can read it a little better, and this will be our exponential function. So what we can do with that function is we can add a third row below balance called the prediction. So let's insert another row, type prediction, and next to prediction, type your function from the trend line that we just created. So we'll say equals 990.56 times, now be careful about your lowercase e. Lowercase e in Excel is exp and then open a bracket. We'll have 0.1645 multiplied times x. Now, you can't type the letter x in here. We have to click on the number of months. Then close the bracket, and this will be our prediction. I'll make a note here where you have an x in the trend line. Click on the months instead. And also make sure to remember your multiplication sign inside the exponential. Because notice we don't write it with a time sign, but we need to remember that it's there. Okay? And so now we can make a prediction for whatever number of months we like. To make a prediction for 2 years, remember that 2 years is 24 months. And we're going to place that in the months row. So in this position, we'll say 24, and then we can just make a new prediction. There you go. We'll paint that. And so we can say that our amount of money after 2 years is $51,342.30. Now for part C, this is a little different because they're asking how many years will it take. To find how many years it takes to reach a certain balance, we use a function in Excel underneath Data, What If, Goal Seek. We're going to make one more entry in our table, but leave the months blank. Make room for it. I'm going to leave the months blank, but I am going to paint that to show that it is unknown right now. We come down here, black cross the formula over one time. Now then we're going to go to the Goal Seek menu. We're going to click on that amount of money. Going to go up here to the top where it says Data, What If, Goal Seek. Now I want this to become $30,000. So in this box that says to value, I say 30,000. By changing cell, the cell I intend to change is the one that I've painted up here at the top. Right now it's blank, but when I press OK, that's going to change. There we are. So my amount of money is 30,000. So remember that when we open the Goal Seek menu, in the second box, put $30,000. In the third box, we put the location of the empty cell above in the months row. And that cell was I11. When we press OK, the correct answer pops up in the months box. I'm going to paint that gold. So it will take 20.73 months to reach a balance of $30,000. Okay, for this problem, we're given a demand function for soybeans and then a supply function that goes with it, where P is price and Q is demand. And they're asking you to find market equilibrium, price, and quantity. So we're going to make an entry for price, an entry for demand, an entry for supply, and then an entry for surplus. Now, we don't actually know what the price or quantity are. So what we're going to need to do is type the demand function here and type the supply function here. And then for surplus, we take the supply minus the demand. So in the demand, we put 3642 subtract 115 multiply times price. Now notice we don't have a number in there for price, but that's okay, because as we saw, we can make Excel figure that out for us by using Goal Seek. For supply, we enter 225, multiply times P. Again, click the empty box, plus 1910. And then surplus is supply minus demand. Just click the corresponding boxes, so equals the supply box minus the demand box. So our answer for price will appear in that position. So we'll paint that gold. We're going to use Goal Seek to change the surplus to 0 if we want the equilibrium point. Once again, we go to Data, What If, Goal Seek. So we start by selecting the surplus box. When we click goal seek, put 0 in the second box because that's what we want. In the third box, we select the gold cell to represent P. So click the surplus box, step 1. Open up goal seek by going data, what if, goal seek. In the second box, to value, put 0. That's step 2. Now for step 3, by changing cell, we click the box I painted gold. And there we go. So our equilibrium price is $5.09. And our equilibrium demand is 3,056.18 units. Now, remember that our units, again, be careful about this. They mentioned that our units are millions of pounds of soybeans. So we'll have a demand 3,056.18 million pounds of soybeans. A lot of the time in MAT-263, they like you to restate your units in terms of whatever the problem said. So sometimes you'll have to refer back to the problem to do your rewrite. Now, they're asking at a price of $6.50, will there be a shortage or a surplus? Well, all we'll have to do is make a copy of these. And now just type our new price into the gold box. $6.50 gives us a surplus of 478. So if we change the price to $6.50, we get a surplus of 478 units. So we can restate that. We'll have a surplus of 478 million pounds of soybeans. Because changing the P changed the surplus. All right. Now example 7. Using the equation demand equals negative 3Q plus 120 and the cost 0.50Q plus 250, find the break-even points. Now, what we need to do to find the break-even point, we need to write an equation for profit. Now, profit is just revenue minus cost. But we need to remember that revenue is quantity times demand. So here's our recipe list for trying to do profit. We have quantity, demand, cost, profit. So for quantity, we have no idea what quantity is going to give us the break-even point. So this is our unknown for this problem. But we are going to paint this gold to show that it's unknown. So now our demand, we can enter our demand function. So we'll say equals negative 3 times Q. That's in the gold box, plus 120. For the cost, we can enter the cost function. 0.5 times Q plus 250. Now for profit, we're going to take Q times demand minus cost. So we'll say equals Q multiplied by demand, subtract cost. Right now it's negative 250, but we can goal seek profit to 0 to find our break-even point. So once again, we can go to data, what if, goal seek. In the second box inside the goal seek, we put 0, and in the third box, we click the gold cell. Now I'm going to go ahead and put a number in for Q to start with. Probably a positive number would be a good starting point here, because this is a more complicated goal seek and there's a lot more boxes involved. We need to tell Excel that Q should be positive, because you can't sell a negative amount of items. So we can start off with some kind of positive number for Q. Doesn't matter too much what it is, but I'm going to make it fairly high, like 200. I'm going to make a point of saying this. So also make sure you select your profit box before you goal seek. So click the profit box, data, what if, goal seek. We want this to become 0 by changing the Q. Press OK. And you might notice you have a very, very tiny number in here. So if you get a number ending in E -07 or some other negative number, that's close enough to 0. Those of you who might have taken chemistry or physics at some point might recognize that this is scientific notation, and E negative anything means a really, really tiny number. So we can say that our break-even point is where our Q is 37.6. So we'll say 37.62, just cut it off at 2 decimal places. In this problem, we have an apartment complex that has 100 two-bedroom units. The manager has determined that the monthly revenue is -0.1x third plus 10x squared plus 400x. And the monthly costs can be estimated by 150x plus 12,000. And they would like us to write a function for profit. Now, let's remember that profit is revenue subtract cost. So our revenue is -0.1x third plus 10x squared plus 400x. Now we're going to subtract the cost. So we're going to go minus 150x and also minus 12,000. Put the little c next to it to show that's cost. Now let's go ahead and put those together. We'll have -0.1x third plus 10x squared. If we take 400 minus 150, we get 250x minus 12,000. And I'll label this with P to show that it's profit. That's the answer to part A. Now, if they want marginal profit, we just take the derivative. So let's go through the derivatives here. If we have a 3 here, it comes down, and the power goes down by 1. The 2 comes down, and the power goes down by 1. The x simply gets thrown away, and the derivative of 12,000, if there are no letters, just becomes 0. So we'll have P prime equals -0.3 x to the second, because third minus 1 becomes second, plus 2 times 10 is 20 x to the first. If we have 250x, just throw the x away and we get 250. And of course, the 12,000 gets canceled out completely when we take the derivative. And so this is our marginal profit function. Now, we are asked, compute the marginal profit when x equals 25 and interpret your answer in the context of the problem. We can use Excel to help us with this. We'll say x is known, it's 25. For profit, we can enter the profit function, -0.1 times x third, plus 10 times x squared, plus 250, minus 12,000. So our profit right now is going to be -$1,062.50. To get the marginal profit, we can enter the marginal profit equation, negative 0.3 times x squared plus 20 times x plus 250. So that means once we've rented out 25 apartments, we get a profit of $562.50 on the 26th. So anytime you're doing marginal anything, that means these 25 have already happened, and this P prime, which is going to be our answer for that problem, is going to tell us how much money we're making on the next one after 25. So on the 26th apartment, we make a profit of $562.50. Part D asks us, how do we achieve maximum profit? To get max profit, we goal seek the P prime to 0. So let's make a copy of what we just did. And we're going to go to Data, What If, Goal Seek. We're going to make that 0 by changing the x. That's going to be this box up here. And we get a negative number. We can't have a negative number there, so we're going to have to specify a different starting point. Let's goal seek again with a higher number to start with, because sometimes Excel misses if you have a starting point it didn't like much. We're going to goal seek P prime to 0 by changing x. There we go. There we go. So this is another example of Excel having two break-even points, okay? So we do have to be careful. So number one, if you goal seek and get a negative x, that's a false answer. To avoid this, you can specify a different x to start from. Of course, if you want to be 100% sure, you can make a scatter to find the break-even points ahead of time. So I'll demonstrate this very quickly. We can make a graph for x and P prime, starting from 0 and going to 100. We'll black cross it till we get 100. And then for P prime, we enter our P prime function, negative 0.3 times x squared plus 20 times x plus 250. And then black cross that. And we can make a scatter by going Insert, Scatter. Option 1 is fine. So if we look at our scatter, we really only have one answer that's positive, and it's a little bit above 70. It's somewhere between 60 and 80. Looks like it's a little toward the high side, around 75 or so. Well, the first time we tried to goal seek this, we ended up with a negative answer, because you can see this curve will eventually drop back to 0, but it's going to do it off the graph, because you can't actually rent out a negative number of apartments. So there's no way for negative 10 to be our real answer. That's a fake answer. Now, when we actually did the goal seek, we found that x was 77.4292. So that's what we should be renting out. The negative 10, of course, doesn't tell us anything useful. Also, if they do ask for the profit at that level of demand, we can say that if we did rent out 77.42 apartments, we would have a profit of $20,889.10.